Okay, hello. My name is Abdul-Aziz Mohammed.
I'm Marissa Jerrells.
I'm Jocquia, Levy.
Bryan, Spain.
And our topic is capacitors.
What is a capacitor? Capacitors are components that are used to store an electrical charge. It's something quite similar to a battery, but a battery generates electricity using chemistry. Capacitors come in different sizes. Now, when a capacitor is connected to a power supply, the electrical charge, as you can see here, goes up into the capacitor, and the capacitor stores the electrical charge. Now, when the power supply is off, the electrical charge slowly starts discharging from the capacitor. Capacitors are used in our daily lives. Consider a flash photograph, for example. In your camera should produce a huge, great burst of light in a fraction of a second when you start to take your picture. There is a capacitor attached to the flash gun on the inside of the camera. What happens is it charges up for a few seconds, aka the capacitor is storing the electrical charge, and it does this by using the energy from the batteries, which the batteries generate. Remember, the batteries generate electricity using chemistry. Usually this takes a few seconds for the capacitor to charge up, which is why you have to wait before you smile for the flash. Once the capacitor is fully charged, it can release all that energy in an instant through the flash bulb.
You consider this capacitor network. Here we have C1 at 6.6 microfarads. We have C2 at 1.1 microfarads, C3 at 14.6 microfarads, and C4 at 6.06 microfarads with the voltage of 12.5. Okay, so the capacitors 3 and 4 are connected in a series network. And they can be connected with the equation 1 over C34 equals 1 over C3 plus 1 over C4, which in equivalent C34 is equal to C3 times C4 divided by C3 plus C4, which will give you your capacitor of C34. Your network will then turn into your C1, your C2, and your C3, 4 with your voltage over here. Your network is then a parallel network where you would add them, where you get C equivalent as C1 plus C2 plus C3, 4.
We're going to continue to go through the equivalent capacitor and plug into the formula. And so this is going to be 6.6 microfarad. I'm going to plug in 6.6 microfarad for capacitor 1, and then for capacitor 2 I'm going to plug in 1.1 microfarad into this equation here. And for the parallel series, I'm going to demonstrate and plug in 14.6 microfarad and 6.06 microfarad. So I'm going to plug in the parallel equation. And so we're going to add the parallel equations together, have it set up correctly to where it is 14.6 microfarad times, so we're multiplying at the top, and so I'm going to multiply this capacitor by 6.606 microfarad, and at the bottom I'm going to add, which is part of the parallel series formula. So I'm going to add 14.6 microfarad into plus 6.606 microfarad. And so I'm going to begin my calculation. I'm going to calculate 6.6 microfarad plus 1.1 microfarad, and I get 7.7. Then I'm going to begin this section of the parallel series and add at the top and multiply at the top and make sure I add at the bottom of the denominator. So I'm going to multiply 14.6 here times 6.06 together. I'm going to get 88.476. So this is going to be equal to 88.476. Then I'm going to add to the denominator of the parallel between capacitor 3 and capacitor 4. So here I get 14.06, 14.6 plus 6.06, and I get 20.66. So I'm going to plug in at the denominator of the final answer of capacitor 3 and capacitor 4. And so I'm going to divide 88.476 divide at the bottom of the capacitor of 20.66. So I'm going to go ahead and solve it now through the calculation. Divided by 20.66, and I get 4.2824 or 4.2825. So it's going to multiply or add 4 plus 2825, and then as the final answer I'm going to add this part of the C1 and C2 together, combined with the parallel series. So I'm adding it all together, and I finally get the answer of 7.7 plus 4.2825, and my final answer is 11.98 equals 11.98 equals the capacity. That's it.
In conclusion, capacitors are components used to store electrical charge, and they come in different shapes and sizes. When they are attached to a power supply, they store electrical charge, and when the power supply is cut off, the capacitors release said charge. If capacitors are connected in series, the equivalent capacitance is found by adding the reciprocals of the individual capacitances and then taking the reciprocal of that result. If capacitors are connected in parallel, then the equivalent capacitance is found by taking the sum of the individual capacitances. These techniques might need to be used in combination to find the equivalent capacitance of a circuit.